In today's session, we will focus on key aspects of a program design and development, starting with an overview of a program design models to understand how the system is structured and implemented. And we will then explore the UML models to which provide a visual way to represent designs, followed by structural modeling, which emphasizes static components of a system. Next, we will delve into relationship in more program design, discussing how various elements interact. Moving forward, we will cover the tools for UML-based design, which streamline and simplify the creation of a design diagrams. We will then look into the class design, a fundamental aspect of object-oriented programming. Additionally, we will explain lightweight design approaches that integrate modeling with coding for iterative development. Finally, then we will conclude with dynamic modeling, which focus on a system behaviors during execution. Then we will delve deeper into more advanced aspects of a program design. We will begin with class design advanced, offering best practices to create efficient and maintainable class. Next, we will explore about a class notation and message notation, which are crucial for visually representing the structure and communication between the components. Moving forward, we will discuss about design patterns and the implementation of these patterns, focusing on how to apply these patterns effectively in real-world scenarios. Bridging the gap between theory and practice, this section will build on the functional concept to enhance your design skills further. This agenda will guide us through the both theoretical and practical aspects of a software design, ensuring a comprehensive understanding of the subject. Program design models aim to represent software architecture in a way that can be implemented as one or more executable programs. This involves specifying programs, components, packages, classes, class hierarchies, interfaces, protocols, algorithms, data structures, security mechanisms, and operational procedures. Historically, program design was handled by domain engineers with implementation left to programmers, as seen in fields like aerospace. Approaches to program design vary. Heavyweight design separate program design from coding using detailed models like UML before coding begins. In contrast, lightweight designs integrates program design and coding is an iterative process, often supported by development tools like IDEs through care is needed to avoid sloppiness. A mixed approach combines these methods using models for outline designs while refining details iteratively during coding. UML Unified Modeling Language is a versatile tool used for planning and designing software systems. It provides a structured way to communicate systems architecture through diagrams that give an overview of the system and detailed specifications for each component. These specifications so ensures that developers can write code with clarity and precision. UML is employed in both heavyweight and lightweight design approaches. In heavyweight design, all the specifications are finalized before coding begins. This method prioritizes through planning but may lack flexibility. Lightweight designs, by contrast, starts with an outline of requirements and refine details iteratively during coding. UML model serves various stages of software development for requirements gathering, use case diagrams illustrate system functionalities and user interaction, such as customer adding items to a cart. For architecture, component diagrams show major system components, their relationship and dependencies, while deployment diagrams map these components to servers or devices. In program design, class diagrams depict the structure and relationships of classes such as users, packing, and order, while sequence diagrams outlines object interactions over time, like processing a payment and updating or an order status. Today, heavyweight UML design has become less prevalent, like lightweight iterative processes gaining popularity due to their adaptability and alignment with modern agile practices. Structural modeling is a crucial aspect of software design that focuses on the static parts of a system, those elements that don't change during the program's execution. It provides a blueprint of a program structure, offering developers an overview of the system foundational components. A class diagram is a prime example of structural modeling. It captures the essence of a system by showing the classes involved, their attributes, methods, and optional references. A class diagram consists of four primary sections. First, it begins with the name of the class, which always start with a capital letter. The naming convention helps maintaining consistency and readability. Second, it includes the attributes of a class, which represents the properties or data fields associated with it. Third section outlines the method of the class, which are the functions and operations it can perform. Finally, an optional fourth section can depict references or connections to other classes, illustrating relationships between the programs. For instance, consider a basic Hello World program. It might include a class named Hello World, which has a method called paint. This method would be responsible for displaying text on the screen. Such diagrams are particularly beneficial as they allow developers to quickly grasp the program structure, simplifying collaboration and decision making. Relationship between the classes are a key part of design. They show how different parts of the program interact. For example, association represents a link between the classes, like the relationship between the library and its book, represented by a solid line with multiplicity at each end. Optional label dependencies show that a change in one class might affect another, represented by a dashed arrow with stick hand pointing to the dependency. Generalization represents inheritance, where a child class shares properties with its parent class, represented by a solid arrow with enclosed head pointing from child to parent. Realization means interfaces. It shows that the class implements an interface or fulfills a contract. Aggregation and composition show how classes are made up of other classes. These relationships help create a clear and logical structure. Now let's discuss about some tools for UML based design. UML designs plays a crucial role in software development by simplifying the process of creating and managing diagrams that represent the system architecture. These tools provide developers with an intuitive way to visualize the relationship and structures of their software. Popular options such as Rotional Rows, Lucidchart, and Visual Paradigm offer user-friendly interfaces that make it easy to drag and drop elements to create a detailed UML diagrams. This accessibility helps teams focus on designing effective solutions rather than being bogged down by technical drawing processes. Often, one of the most valuable features of many modern UML tools is their ability to integrate directly with source code. These tools can generate diagrams automatically from the code base or extract detailed specifications from developer comments embedded in the code. By automating these tasks, teams can significant time and effort, reducing the need for repetitive manual updates. This ensures that the design documentation stays consistent with the actual implementation, a key feature in maintaining code quality and alignment with original specifications. For lightweight design approaches, a full-fledged UML tool isn't always necessary. It's not always necessary. In such cases, a simplified white box sketch or even a quick drawing on a paper can be enough to brainstorm ideas and communicate high-level concepts. This method works well in smaller teams or during the initial phase of the design, where flexibility and speeds are prioritized over formal documentation. Designing the class is another crucial step in program design as it lays the foundation for system structure and functionality. The process starts with identifying the main elements of the system that represents either real-world entities or logical components. For instance, in a class of library management system, core classes might include books, members, and staff. These classes accurately represent the system's keys, elements, and responsibilities, acting as a building block for the overall program. Each class should have a clear purpose with its attributes and methods aligned to fulfill its responsibilities. Attributes represent the data the class needs to store, such as book's title and author, while methods define the actions the class can perform, like issuing or returning the book. This ensures that the functionality of each class directly corresponds to its roles within the system, reducing confusion and redundancy. After identifying the initial set of classes, it's important to refine the design to enhance clarity and efficiency. This may involve splitting over complex classes into smaller, more focused ones or merging similar classes to eliminate the duplication. For example, a single user class might be split into separate member and staff classes if their roles are sufficiently distinct. Conversely, two nearly identical classes such as print book and e-book could be merged into a single book class with additional attributes to distinguish their formats. Dynamic modeling is a key aspect of software design that focuses on how the system behaves during execution. Unlike static models, which highlight the system structure, dynamic models capture the interactions and changes that occur over time. These models are particularly valuable for understanding complex workflows and ensuring that different components of the system work together seamlessly. One of the most common tools used for dynamic modeling in interaction diagrams, such as sequence diagrams. A sequence diagram provides a visual representation of the flow of the messages and operations between the objects in a system. For instance, in a student management system, a sequence diagram could illustrate the process of changing a student programs. It might it might show how a request is initiated by a user, processed by the system, and how responses are generated, such as updating records and notifying the student. These diagrams are not just static representations, they emphasize the timing and sequence of the events, making it easier for developers to understand the precise order in which operations occur. This clarity is crucial for identifying potential issues such as bottlenecks or incorrect dependencies between the components. So now in the last we discuss about some design patterns which are the essential tools in software development that provide reusable solutions to common design problems. They offer developers a structured and proven approach to addressing recurring challenges, promoting both efficiency and consistency. By relying on established patterns, teams can save time, avoid reinventing the wheel, and ensure that the design aligns with the industry best practices. One widely used example is observer pattern. This pattern is particularly effective in scenarios where multiple components need to stay updated when a single object changes. For instance, in graphical applications, a user action such as resizing a window might need to trigger updates in multiple areas, such as adjusting layouts or refreshing display data. The observer pattern simplifies this by allowing components to automatically react to changes in central object without being totally tightly coupled to it. Each design pattern has a specific name, making it easier for developers to reference and share ideas. Moreover, patterns define a clear problem, outline a general solution, and provide flexibility for adaptation to different contexts. Importantly, they also identify potential consequences, helping developers weigh the trade-off between them before the implementation. For example, while the observer pattern reducing coupling and improves modularity, it can make the control flow more complex and harder to trace, especially in systems with numerous observers.